booklet. Do you have out the piece of paper we were doing a little work on in the back? Yesterday we talked about exponents, yes, but specifically 2 rules. What rules did we discuss? What were the 2 properties we discussed yesterday? Multiplying and dividing. Okay, when we're multiplying like bases, what do we do with the exponent? We're multiplying, we add. Okay, so let's look inside our booklet. We had that example, and we were supposed to do these 2 problems for homework. Everyone seemed to have these correct. We add the exponents, so our answer would be x to the 7th, y to the 8th. 3 plus 4 is 7, 2 plus 6 is 8. Make sure you only add the like bases, meaning the x's go together only, the y's go together only. On the second problem, you should have gotten a to the 8th, b to the 6th, because 4 plus 2 is 6, and then c to the what power? To the 7th. This is where some people messed up. There is an understood 1 right here. So when we multiply, we're actually doing 1 plus 6, which is 7. So if you didn't know that, that's something I would write on my paper. Any exponent that doesn't have a variable, it's understood to have a 1. It's really c to the 1, x to the 1, y to the 1. And heck, numbers are like that too. If numbers don't have an exponent like 2, 3, or 4, they're understood to be 2 to the 1st, 3 to the 1st, 4 to the 1st. There's an understood 1. The way when we work a problem like this, you know there's an understood 1 in front of the x. It's really 1x plus 3y equals 4. We just don't write the 1. We call it understood. In the same way, if they don't put an exponent, it's understood to be a 1. Okay? Are there any questions other than that one? I saw some people had messed up the c to the 7th. Okay, and then on the next ones we need to subtract. So 9 minus 2 is 7. 3 minus 1, because there's an understood 1, is 2. 1 minus 7 is negative 6. Oh no. I saw one person had left it like this in their booklet. They would not get all their points. It was not you, actually. Was it you?
I haven't left yet.
Oh, well, no. It was not you that I was thinking about. That they would not get all their points. They are not done. We talked about something that concerns us.
Put it over 1 and make it positive.
Yeah, we cannot have what's the issue right now? No negative exponents allowed in our final answers. We punish them and send them to the denominator. So, I know, so I'm going to write this on my side paper. I know most people on their paper had a to the 7th. My booklet is just too tiny, and I have so many thoughts. I know most people on their paper had a to the 7th, b squared, and then they had 1 over c to the 6th. They punished them and sent him to the bottom, like Ty said. You get punished. You go where you don't want to go. He was in the numerator, so he got sent to the denominator. However, that's not the answer I'm going to write in my booklet. Wouldn't it be prettier if we had a to the 7th b squared? They're in the numerator. They're not in trouble. They can stay on top. C to the 6th in the bottom. That would be a prettier, better answer. If you did not have that prettier, better answer, please add that in now. So, a to the 7th b squared all divided by c to the 6th. That is the answer we're looking for. One giant fraction. Now, I said this in 4th period. You know they have me a little longer than you, so I got to look at most of theirs yesterday. There was at least one person who tried to send everybody to the bottom.
Why?
I do not know. You only get sent somewhere if you're negative. You only get to move if you're negative. So the only reason we move c to the 6 is because before we had c to the 6 in the numerator and he was negative. If they're not negative, they don't go anywhere. You can't suddenly push them to the bottom or push them to the top. Technically, when you move them to the bottom, you've changed their sign, and now it's technically a -7 and a -2. We want to be real crazy with it. That's why they got to stay where they were. They were good when they were on top. They misbehave when they're in the bottom. Put them wherever they behave. Now, I know the person, or I guess I'm telling you too, whoever left in the negative exponent, I get that you think this rule is silly. And it's not that I don't also think it's silly, because I do. But it is a math thing, and we cannot, and I will not be able to give you all your credit if you continue to leave negative exponents in your final answer.
Wait, I have a question.
Yes, dear.
Technically, where does that 1 go then?
You know it's understood in front right now. He's understood there. You don't have to write him. He's understood. He's understood to be there. The way he's understood to be there in an equation. We always know there's a secret one in front. We just don't write him because we're so smart. We just don't have to write him. Is what I'm going to say. We just don't write him. He's understood. Okay, and then our second homework problem from last night was a bit of a doozy. So I'm going to actually write it all out. So you did 2 to the minus -6. So you ended up doing 2 plus 6, which is x to the 8th. You did 4 minus a -4, which ended up being plus 4, so y to the 8th. And then z to the 7 minus 3, hey, that one's easy, which is z to the 4th. So I did 2 minus -6, which is 2 plus 6, which is 8. 4 minus a -4, which is 4 plus 4, which is 8. And z to the 4th. So that is my final answer. Now, if that is not something you understood, you don't understand how I did 2 minus -6, 4 minus -4, 7 minus 3. If that's not something you understood, I have an alternate way. Yes, ma'am.
Wait, so you're supposed to add those together? How do you subtract?
Yeah, I subtracted, but when I subtract the negative, you know it's addition. I'm subtracting a -6. 2 negatives make a positive. Okay, this is how Miss Compton would have done it. I am like you. I go through the whole problem. Negatives don't bother me in life. I go through the whole problem, and I only fix the negatives at the end. If I have to. Like, if the end has a negative, then I fix it. Thankfully, the end didn't have a negative. I don't have anything to fix. But I do want to show you an alternate version. And if I were you, I'd write it on my sheet. No. Okay, so you had the problem x squared, y to the 4th, z to the 7th, all divided by x to the -6, y to the -4, z to the 3rd. Thank you. This was the problem you had for homework last night. We're going to end up getting the exact same answer. I'm still going to get x to the 8th, y to the 8th, z to the 4th, but I'm going to solve it a little differently. What if, instead of immediately starting to subtract, we punish the negative people? What if we punish them? So how do I punish x to the -6? Okay, so I'm actually going to have x squared, x to the 6 in the top, and I'm going to have y to the 4th, y to the 4th in the top. And the reason I've sent these two to the top is because they were in trouble because they were negative. I am not going to send z cubed to the top. He is not in trouble. And now they're no longer negative. That's why we punish them, because we cannot have them being negative. Now, you understood how we sent them to the top. We sent them to the top because they were negative. You would have been fine if it weren't for all this other stuff in the problem. Okay. No, I'm just showing you an alternate way because this might be useful in life. Now, this problem ends up being, instead of a division problem, it's really a multiplication problem, because I'm going to do x squared times x to the 6th. Well, I add, and I get x to the 8th. Y to the 4th, y to the 4th, I add, I get y to the 8th. And then I'm only having to use the division property on the z term. 7 minus 3 is 4. I end up getting the exact same answer. So, moral of that story is either you can fix the negatives to begin with and solve, or you can work out the whole entire problem and fix the negatives at the end. But if you're trying to get your points from me, there cannot be negatives in your final answer, negative exponents. Okay, are there any questions about that? Would it be smart to maybe, if you understood, to do both and check yourself? Of course, you know I always think it's a great idea to check yourself in math class. Okay, before we go crazy today, there is one secret thing I want to talk about. Actually, two secret things. So, I don't know, did you tape your white strips in? Glue them so they can't bend down? Okay, perfect. Well, let's flip to the back of the book. We're going to put our secrets on the back. They're really not secrets, but we're going to call them secrets. There are two secrets that we should probably discuss before we go any further. Actually, there are three. Let's go ahead and list the one that you're confused on today. C with no power is understood to be C to the first. That's one of our secrets. Another secret is that 1 raised to anything is always 1. I think you knew the second secret. And then the third secret is my favorite, because you know it involves one of my favorite numbers. Anything to the 0 power is always 1. Anything to the 0 power is always 1. And that seems counterintuitive. You would think it would be 0. But what we mean by the exponent, so let me go on my little side rant because I can. 2 to the 3rd would mean I have 2 3 times. I'm multiplying it 3 times. So 7 to the 0, well, it's not like there's nothing there. There's always an understood 1 there. That's not a really good explanation, but I don't really want to go into my whole little math world. You know, I could pull out my book and read a chapter on this one. I didn't think we wanted that today. If you're questioning me and to the 0 thing, you need to type it in your calculator. But anything to the 0 power is 1. Okay, and then we're going to come back and have a fourth secret in just a second. But I thought you should know that they could potentially put something really long, and I would love to do this to you, like 1x, I'm going to do 13x squared plus 4y squared minus 3z all over 2xyz cubed. A giant thing that looks like that makes you start sweating. And I raise it all to the 0 power. So the answer for the whole giant thing is still 1. They love to do that kind of thing. The whole giant thing, no matter what it is, if it's raised to the 0 power, it can be 1. Yeah, it stinks, but I'm sorry.
Can we gossip about it?
No, that's not. I'm not putting number 4 yet. You don't get 4. You don't get 4 yet. Okay, I gotta slip my thingy back in. I pulled out my column and now I gotta put it back in my book. Our next little flap is gonna be power to a power. So we multiplied, we've divided, now we've got to raise a power. Again, I'm pretty sure most of us know these rules already, but we just gotta fine tune it and make sure we've got it 100% down. Oh my goodness, I pulled out my other thingy. Oh my gosh. Okay. Power to a power. Now, before we go crazy, remind me, in this example, what is the base and tell me what's the base? This one from yesterday.
Big number or variable size.
Okay, but what is it in this one? L, thank you. Okay, and then we call that tiny thing what? Or another word for that is power. And then if it was a cool one like 3, we would say what vocab cubes. Thank you. Okay, so power to a power is when we're doing, it already has one exponent, and we're raising it to another exponent. Now, when you multiply like bases, you add the exponents. When you divide, you subtract the exponents. What do you do when it's a power to a power? You multiply the exponents. So we're going to do 3 times 4, which is x to the 12th. A power to a power. Okay, so flip your flap. That's funny. Okay, we are going to multiply the exponents, or multiply the powers. And we need to work a couple more problems to make sure we got it down. I think we're going to do 3. It's fine if you have multiply the powers, it means the same thing. It means the same thing. Okay, if I had U, Hannah has a U on her sweatshirt. U to the 8th raised to the 3rd, what would I get?
8 to the 24. U to the 24.
U to the 24. Thank you. And then, you know, of course, I gotta make this a little more fun. So, JD has an H on his binder. What if I do H squared raised to the negative 5? What would I get then? You can tell me the intermediate step, but someone's got to fix it by the end. Okay, Josh said H to the negative 10. Is Josh getting all his points today? No. What does he need to write after that? Okay, 1 over H to the 10. I said I would take the intermediate step. I did say it. It shouldn't be negative H. I got to get my white out. It needs to be 1 over 8 to the 10. My book's been messed up. Don't even know where that is. Because it was on John David's binder.
It's on your binder.
Don't even know. Okay, so of course I've got to give you 2 to do for homework, which I know you're going to have done by the time I write them down. So your homework for multiplying a power to a power is A, C to the 4th raised to the 17th, and B, D to the 5th raised to the negative 9. Are there any questions about a power to a power?
Do you solve it the same when you have like multiple and parentheses, and then when it's like, say it's like ages?
Ooh, I like that idea. So we had room for one more. I said 3. Hannah has a good one. Let's do that. Hannah. I know. Can you believe Hannah wants to do math in math class? It's ridiculous. Freaking ridiculous. Like this?
No, I'm talking about like, well, I mean that too, but like when it was like C4 and then D5 and 1.
Oh, that's what we're going to do in the next slide. But yes. But if I did this one, what would I do?
I don't know. Multiply the inside, then multiply the inside by the outside.
Yeah, so when you end up multiplying them all. So I do 2 times 3, I get 6.
So A to the 24th?
Raised to the 4th, and I end up getting into the 24th. If you just wanted to multiply them all to begin with, you'd be right. Yes. Thank you, Hannah. I knew that I wanted a third example that was more fun. Thanks, Hannah. Okay, and but. No, I'm not going to say that yet. Okay, flip to the front flap. I got to give you the last secret. Actually, you know what? We'll save the last flap till tomorrow. Because, you know what I forgot to pass out yesterday and I'm not going to forget today? Your homework that's due on Monday. So I'm going to let Josh pass it out to you. What category did I say it was going to go in? It's 3 pages. It is not on exponents. It is just on inequalities. If you want help, come see me.